Hello and welcome to this Plastics training session. In this video, we will cover Module 2, Unit 2.3, Enzymatic hydrolysis, demonstrating mixed textile waste recycling at pilot scale. The focus of this module is to demonstrate the enzymatic recycling process described in Module 1 at pilot scale, and it will cover all steps from textile sorting to the chemical processing and recovery of the materials, and the yarn spinning and fiber production. My name is Barbara Liedl and I'm a researcher and project manager at the TCKT. In Plastics, we're involved in various tasks, but mainly we're the leaders of the work package Chemical Recycling of Textiles through Enzymatic Reactions. We're demonstrating the recycling at small pilot scale in our facilities. Mixed textiles are considered to be not recyclable when they end up as waste. However, enzymatic hydrolysis can be a way to separate mixed textiles into their components and enable a recycling. In Plastics, we demonstrate this approach of recycling textiles along the entire process chain up to pilot scale. To give you some background infos on the importance of this topic, 5.8 million tons of textile waste are thrown away by consumers every year in the EU alone. The vast majority of textile waste worldwide is landfilled or incinerated. Only 25% is reused or recycled to products other than textiles. And only 1% of the waste is recycled into textiles again. Modern clothes comprise of several fibers. Besides cotton and polyester, wool, silk, polyamides and other synthetic fibers are commonly used. Rising awareness of the ecological problems caused by tons of textile waste calls for the use of this waste as a resource. However, the recycling and reuse of the mixed fabrics pose a challenge and requires breaking them down into the individual components. The enzymatic hydrolysis applied in Plastics is an energy-efficient process to separate selected components. In this module, we will cover the entire process of textile recycling, from sorting to fiber production, and take a closer look at the individual steps and how they are implemented and demonstrated in Plastics. Recycling starts with the sorting process of discarded textiles. Those textiles which can no longer be reused are suitable for recovery in a recycling process. As textiles can be made of various fibers, the actual composition is not always clear. The technology we apply in Plastics to target and sort out the waste streams we are interested in is near-infrared spectroscopy, NIR. NIR uses infrared light that is either reflected or absorbed by a sample, depending on its chemical structure. The data are then converted into a spectrum, revealing the composition of the measured textile. In this way, cotton and polyester fibers can be differentiated due to the different chemical structure. In our technology, we dissolve the cotton part of a garment and recover the polyester fibers. So we target the waste stream made of these two fiber types, preferably with a polyester share higher than 50% to keep the process efficient. The sorting technology is demonstrated at the Kriewinkel Antwerpen. The preparation process starts with shredding the textile waste to smaller pieces. This can be done with cutting mills. Cutting the textile garments is also important to remove hard parts that are not actual part of the fabric but appear a lot in clothing, like buttons and zippers and so on. These hard parts can be removed by metal separation or wind sifting. TCKT has the equipment to shred textiles at pilot scale. Before the actual hydrolysis, a chemical pre-treatment of the fabrics, where they are immersed in alkaline solution, is necessary to make the cellulose susceptible for the subsequent enzymatic reactions. The alkaline pre-treatment is demonstrated at small pilot and pilot scale by TCKT and Austrocell. The alkaline pre-treatment is directly followed by the actual enzymatic recycling process, the hydrolysis of cotton. For mixed fabrics, this means that the cotton fibers are degraded into sugars, which are soluble in water. The polyester fibers are not affected by this reaction and remain as they are. The remaining polyester fibers are then filtered off, washed and dried before they can be further processed in the recycling process. And also the sugar solution is not discarded, but can be reused as a feedstock for the production of, for instance, bioethanol. These processes are demonstrated by TCKT and Austrocell. The so recovered polyester fibers can then be extruded to granules. Before, they have to be carefully washed and dried. These recycled polyester granules are tested if they achieve the required properties for further processing into fibers again. TCKT and Centexpel have the plastic processing possibilities and the testing machines to demonstrate the conversion of the recovered polyester fibers to spinnable granules again. Fiber spinning of the recycled granules, yarn production and consequent fabric production close the loop in fiber-to-fiber recycling, from waste to textile clothing again. Fiber spinning, yarn and fabric production, as well as all related tests to these process steps, are done at small pilot scale and pilot scale at Cortex and Sun Textil. With this unit, we showed that the complexity of textiles recycling can be overcome with energy-efficient separation technologies, such as enzymatic hydrolysis. These recycling strategies need to be implemented at industrial scale in a way that all individual components are reutilized. In Plastiles, we demonstrate such a closed fiber-to-fiber recycling process at pilot scale. This concludes Unit 2.3. Thank you for watching this training video. Stay tuned for the next module where we'll continue exploring innovative technologies for circular plastic value chains.